Today I'll be doing some destructive load testing in my shop press. I have a bunch of different samples from 4 different manufacturers, and I'm basically just testing to make sure they use the right material and they perform as expected. 6 tons. It's going a little crooked, buckling a bit. 6 tons still. 6.5. Nine tons. 9 tons. That's as much as I can do without breaking the handle on my press. 1 ton. 2 tons. 3 tons. 4 tons. 4.5. Buckling a little bit, bulging a bit in the front. Still 4.5. 5 tons. Really crooked now. 5 tons. And that was interesting. 7 tons. 8 tons. No visible effect. 9 tons. 8 tons. Still good. 8 tons. 8.5. 9. A little bit of bulging at the bottom of the cap. 8 tons. 9 tons. 8 tons. Just some adenizing cracking at the top. 9 tons. Ooh. Just a little bit of buckling where the cap and base meet. Besides that, looks good. 6 tons. 7 tons. 8 tons. 9 tons. Nothing visible. Looks good. 1 ton. 2 tons. 3 tons. 3.5. 4. Starting to crush a bit. 4.5. Noticeably deformed now. 5. Very deformed. 6 tons, 7 tons, 'still looks fine, 8 tons, 9 tons, 6 tons, 7 tons, 8 tons, 9 tons, 1 ton, 3 tons, 3 tons, 4 tons, 5 tons. Oh, yeah, I crushed it there. 8 tons, 8 exactly crushed there at 8.5 tons, 8.5 tons. 6 tons. Oh, 6.5 tons. 7 tons. Something's going. Yeah. 7 tons. 8 tons. Oh, 9 tons. 6 tons. 6.5. 7. 8 tons. 9 tons. So here's a quick summary of the load testing results. I found that manufacturers A and B used a slightly lower strength aluminum alloy, and I can tell that by 2 ways. One is the failure loads were a little bit smaller, and 2, the way they failed. So a lower strength aluminum alloy is a little bit ductile, so when it fails it sort of slowly deforms like this one. Whereas a higher strength aluminum alloy is more brittle, so when it fails it basically shatters like this one. So that verifies that manufacturers C and D use the higher strength aluminum alloy that I asked. Another thing I found was the failure loads were a little bit higher than I expected. I did some stress modeling in AutoCAD Inventor, and for example on the side load for the aluminum, I estimated it to be around 4 tons, where I actually failed it closer to 7 tons, so that's almost twice as much. So that's good, a little bit stronger than expected. So that's it for this load testing video. Thanks for watching.